Hi, my name is KSpoerl, and today I'm going to be talking about the signal transmission process inside a simple radio system. So the radio system that we're going to be looking at today is the kind that you might be able to find inside a simple smartphone. We're going to be looking at the technical aspects of this radio system, uh, key, key components of which being the preamplifier, the mixer for the system, the bandpass filter, and the antenna of the cell phone. So we're also going to be analyzing why the system is designed in the way it is, and more specifically, why when we give an input signal of our voice, first we uh, pair it with a carrier frequency before we transmit it out of the cell phone. So the first technical component that we're going to be analyzing is the preamplifier, which is demonstrated right here by the combination of a current mirror and a common source amplifier. So this preamplifier is very important because it allows for multiple things to happen to the input signal before it gets mixed with the carrier signal. So it allows us to amplify the input signal, which is a very important process. By increasing the signal's gain, it might become clearer. It also allows us to condition this signal before we pass it into the mixer so that it can be properly put together to be combined with this carrier signal that we're going to introduce in the next step. This preamplifier also gives us the opportunity to filter out any noise that might be around the input signal, uh, which is also very important. So the next component we need to talk about is the mixer for the system. Uh, this mixer, it generates sinusoidal waves uh, that come from an oscillating electrical and magnetic energy. And the way this works is as the capacitor discharges energy from this real LC tank, it will be transferred to the inductor of the system. And then after that works, it goes right back to the capacitor. So the rate at which this transfer of energy occurs will be the frequency of this sinusoidal response that we see right here. Now, this isn't a pure signal because there is a parasitic resistance. So in the design of this system, it will be very important to recognize that the wires between the capacitor and the inductor have implicit resistances. So you will have a decay in the sinusoidal signal due to attenuation. Uh, so now, when we combine these signals, it's considered signal multiplexing. And why? Why do we use signal multiplexing? Well, first off, it's key to note the physical components involved in transmitting the signal over the air. We have our antenna length, which is controlled by c over f, which is our speed of light over our frequency. So how it works is the lower the frequency that we're transmitting, the higher, or sorry, the longer the antenna for this transmission process has to be. So for example, human voice is generated anywhere between 1 kilohertz or 300 hertz and about maybe 6 kilohertz. So if we were to take a stable 3 kilohertz input and we were going to try and transmit that over the air, we would need an antenna somewhere within the order of 100,000 meters long, which is very, very impractical. So instead, what we do is we combine this voice input with a carrier frequency that is uh, that has a much higher frequency than the voice input otherwise would have. Now, say we bump this carrier frequency up, we can get the antenna size that is required down to millimeters and centimeters, which is much more reasonable considering the devices that we're transmitting these signals from. What this also allows you to do is it allows you to transmit signals concurrently with one another. So how that works is if you give different cell phones slightly different carrier frequencies, you're able to transmit them both at the same time over the air without them getting muddled. So this is also environmentally adaptive. So different environments that you might want to transmit a signal through, they're going to have different frequency responses. So it might be very susceptible to high frequencies, somewhere in the middle range, somewhere on the low end. So by choosing a carrier frequency with the environment in line, you can cut out a lot of noise that you otherwise might have. So now we need to talk about receiving these signals with the bandpass filter itself. So this bandpass filter is a very, very important part of the system because what it allows us to do is it allows us to separate these concurrently transmitting signals. So if you have a signal somewhere around the range of 20 kilohertz, and you have another signal somewhere around the range of 21 kilohertz, another signal around the range of 19 kilohertz. But you really care about the signal at 20 kilohertz. So you design a bandpass filter, like the one shown here, with different components that allow there to be a maximum gain for that system peaking at 20 kilohertz. And you design it to be a tight bandpass then, so it quickly cuts out the signals from the other frequencies. And what that allows us to do is it allows us to pick out a signal from a crowd of other signals. So this has been a brief description of how a radio system transmits a signal from a cell phone and how you can possibly receive one from your cell phone. Thank you for watching.